Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. As promised during our studio session, I've told you that I will show you how we could make screw. Screw is part of our SolidWorks projects plus suction cup mount holders. So as can be shown in this image, actually this is not screw, this is a pin. What I mean is this screw will be put into here in this hole. Okay, so we have in a thread here, so we have a screw will be fit into here, into this hole. So sometimes this screw is a standard component. Sometimes you can import that standard component if you use the SolidWorks library file. If you register on a website called 3D Content Central, sometimes they have a certain standard components like screw, spring, and other mechanical standard components. There's a case there where, like this kind of screw, you cannot directly give you that website that cannot give you the exact your component specification that you need. So at last, normally you will do it on your own. Of your your component is a single screw. So in this case, I will show you how you do a basic screw here. So this is what we call a kind of screw. So we have a hemisphere head here, like a dome shaped head. So then we have a screw body here. If you look on the basic body here, we have a cylinder with constant diameter until at one point the diameter decrease into 0. So we have kind of tapered curvature here until 0 diameter. So I have already measured the dimension of the screw. The length of this thread area, not including the head, is 19 millimeter. And if you look, we have a screw thread here. It's a V-shaped thread. The V-shape, the size of the V is 0.8. And we have a number of revolutions here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, until at the end here we have 12 revolution. So we have a total length of the thread area is 19, and if you look through this image, we have until the thread area until I think about 14 millimeter. We have constant diameter radius, and we have 1, 2, 3, 4, 5, 6, 7, 8 revolution until 14 millimeter, and additional 5 millimeter we have decreasing diameter until 0. Additional 5 we have we have 1, 2, 3, 4 revolutions, so the diameter is 0. So okay, I will show you how we do this in SolidWorks. Okay, so let's start our file. Okay, we start a new file. So since the diameter of the pin, the basic cylinder here is 2 millimeter, so we make in our top plane, make a sketch. So we put diameter is 2. This our, let me zoom to fit. So this our circle shape. Okay, then we exit the sketch. Then we go to insert. We have curve here, under insert curve, we use helix or spiral. So basically, initially when you use this helix spiral, you will set your parameters to constant radius. Okay, constant radius. Constant radius means that if you want to do basic screw shape without, in our case here, we will do it in not constant radius. We will do it in variable pitch, since in this image we have decreasing of our radius of our spiral at this end point here. So what we'll do is we use instead of using constant pitch, we use variable pitch. So the option here, we use height and revolution. Okay, height and revolution. Okay, let me drag this, make it wider. So we have if you look on the settings here, at the beginning here, we have at our height 0. At our height 0, we have revolution is 0. So and our diameter is 2. Diameter is 2. Since in this image, the total length is 19. From here to here is about 14 millimeter. 14 millimeter is, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 revolution. 8 revolution, where the diameter of the pin is constant, 2 millimeter, and we have 8 revolution. Okay, so in this setting, under 14 millimeter, at 14 millimeter, our revolution is 8 and our diameter is 2. Okay, so we have the setting here. If you look here in this dialog box here, we have for height 14, revolution is 8, diameter is still 2. But from 14 millimeter to 19 millimeter, so the diameter is decreasing to 0. So we have since total revolution is 12, we have 8 for constant radius and another 4, 1, 2, 3, 4. We have 4 revolution there, another 4 revolution. Okay, we have another 4 revolution, and total length is 19 millimeter, and the revolution is 12. Okay, and the diameter here is if you put 0, so it will pop up. You need to put the value is like at least 0.001. so what you need to put here is 0.1. okay, 0.1. If you look at the spiral here, the helix here, so we have until 8 revolution, 1, 2, 3, 4, 5, 6, 7, 8 revolution. We have a height 14, we have diameter 2 millimeter, but we had another 1, 2, 3, 4, another 4 revolution, where is total 12 revolution, the diameter is 0.1. okay, from 8 to 12 revolution, the diameter is 0.1 is close to 0. Okay, then when we click, okay, make sure that the start angle is 0. Your start angle is 0, and either you want to is clockwise or counterclockwise. In this case, we use clockwise. Then we click OK. So we have the helix, the basic helix shape. Okay, the next thing is you go to the right plane, the correct plane. In this case, we will use since if you look, if I zoom it closer, so we have our starting point here at 0 degree angle. So if we use the right plane, not the front plane, we use the right plane. So the right plane will be is a suitable plane for us to do our cross section for our thread. So we use the right plane, and you make edit sketch, and we go to normal view, So in the normal view, in this right plane, so you can put your cross section. Okay, you can put your cross section here, your V-shaped cross section. So the size of the thread is about, let me draw a rectangle here. So our side is 3. So we make first our rectangle to this orientation. Okay, then the length of our rectangle is 0.8. Okay, 0.8. Then we click OK. Then we got to move our cross section into this path here, this helix. So what we'll do is we select this line, we right click, we select the middle point of it, and you hold down your control key, but you don't click at this end point here. You click at the helix path here. So then you have a relations, add relations. You click on not coincident, you use pierce. So pierce is what you will put the cross section directly into your path starting point here, the origin here. Okay, you use pierce. Okay, then we click OK. Then we have our setting to make sweeps, to make the thread. Okay, then we go to features, then we exit sketch. Then we go to features, we use swept boss. So our cross section is already selected. Then our path, we select the helix. Then you click OK. Okay, now we have our helix geometry. The next thing to do, if we need to do the pin body. Okay, in this case I will use in the front plane or right plane, draw the section, and we use revolve. We use revolve of our cross section. Okay. Okay, the next step is, since we look in this isometric view, so it should be, if you look on the profile here, the triangle shape of this thread. So we should go to the right plane to make our basic cylinder object. So we go to make the right plane active. So you go to normal view. Okay, then the first thing to do is we should draw the cross section of the pin. Okay, we draw the cross section of the pin with the diameter of 2, and then we make a revolve. So let me draw the cross section first. So we drew line, we zoom at this corner. So we have line at the, make sure that let me draw the center line first. Okay, we make the center line. Zoom out. Okay, make center line, then draw a straight line. Until it reach, if we certain point, then the diameter will reduce. So until at least about 14 millimeter, until at this point the diameter is constant. Okay, the diameter is constant, and at this point then until about this endpoint there, and we go horizontal line, and we zoom out, and we close the cross section. Okay, make sure that we delete this the constraint, we delete it. Then we put a dimension of 1, since the diameter of the cylinder is the dimension is 1. Okay, to make sure the dimension is 1, then we make some adjustment. We put some fillet at this end point with a radius of if I do some fillet, there will be a gap here. So if you do revolve, so SolidWorks will do there will be error, since we have a gap, so it cannot form a solid object. So instead of doing fillet, let me put a dimension here first. As I mentioned, the dimension is about 14. Okay, dimension 14. Let we put it 15. Okay, 15. Another thing is I should this point, this end point should be coincident. Okay, let me undo it. Let me delete this thing. I delete this dimension first. I delete it because it's set already a constraint there, so I need to do some adjustment at the bottom here. So this line and this point should be coincident. So okay, and then we put some adjustment here, and let's see, we delete this relationship, and let's put little bit upward, so that the material, it will not form any gaps here when we do revolve. So let's put some fillet here, and I cancel fillet, make it increase it a little bit. Let's do it some fillet. As long the fillet, it will not form any kind of gap there. let's say the fill is about 7. Okay, I think it should be okay. So we have some curvature here, and also if we do some little bit adjustment. I think it should be okay for this profile, and as long as our cross section is good enough to form a basic. The idea is not to form any kind of gap when you do revolve. So as long as we have the right if I okay, then if I do some revolve. Okay, exit go to features, then we do revolve base, then we click OK. Okay, let's wait. Sorry for having quite right, so okay, let's do revolve. I do it again. Okay, when we try to do revolve here, sometimes when you do features, when we use revolve, the axis evolution in this axis, when you click OK, sometimes the SolidWorks will not give you the end result. So it means that either the cross section of the thread have to be moved little bit, the cross section of this V shape of this thread have to move inward, so that the material will be combined to form solid. So in this case, I don't want to move the cross section of this thread. I want to little bit increase the diameter of this basic pin. So let me zoom this part, and we have a constraint here. It means the starting pointer is a little bit snap at this end point, so I delete this constraint. Let me off this one. This constraint I delete it, so let me move it little bit as long the profile of this cylinder will be little bit, we move it little bit to the right, so it will the material will merge together. Yes, let me zoom this little bit closer, and don't move it too much, just slightly. We move it slightly as long we have some inner what we call it, inner intersection there, so we have to make a little bit to the left. Okay, then let's do some I hope it could do revolve. Also let me do revolve, and this let me clear this one. Our axis of revolution should be this line. Then we click OK. Alhamdulillah, so we got the our screw part. Okay, our screw. So we have 12 revolution there. Okay, we have our screw. Then the next part is to do our screw head. Okay, the screw head. So we just rotate it, go to the bottom view. So we don't make the sketch plane on the top view. So what we do? So let's go to the isometric view first. Okay, so we can form the screw head by also revolve, by drawing the profile to be revolved. So let's do it on the either front plane or the right plane. Let's try right plane, and we make some sketch on the right plane. Then we go to normal view. Then we draw the profile of the dome shape for the screw head. Okay, if you look on the image, we have kind of profile of dome shape here. So as long the diameter of this dome is 5, and the height is about 2. So let's draw that profile in the SolidWorks. So let me start by drawing lines at that point, and we make some profile, and let's go for arch. Press A, and okay, then we put a dimension. Okay, we put a dimension since the diameter is 5, so the dimension here will be 2.5. Click OK, and the height is about 2. I think, yes, I think it's about right. So we have 2, and we have profile there. Then we do revolve, and our axis is this line. Then we click OK. Right, so we have formed the screw. Okay, the screw for. We have not finished yet. We have another part here. We have we can do cutout section for screwdriver to tightening the connection. Okay, or fastening. Okay, we need to do on this plane. In this image, it's not shown here. You cannot see it through this side view. So we have a cross section that we can use cut extrude. So let's go to, as long we have this flat surface, we make it a sketch plane. Then we go to normal view. Then we draw. Okay, it's our normal view. So let's draw a rectangle. Let's try a rectangle, center rectangle. This line we make a rough rectangle. Then put a dimension of let's try is 2, and this, the width is, let's go for let's try for, what about 1? Oh, 1 is, let's try point. Let's go for 0.75, and this one is 3. is our then we have another rectangle here. We use the same center point rectangle, center rectangle, and we use same dimension. We have 3 and 0.75. Okay, let's do some trimming here. After we have done the sketching, so we can do actually I don't know the exact size of for the screwdriver head, so we need to do some measurement here. So there is a roughly estimation. I just roughly estimate the dimension of the screwdriver head. Okay, then we do some features, extrude cut. Make sure that our direction is downward, so let's put about 2 mm, not 2 mm, about 3 mm. Make sure that it's not pass through this the screwdriver head here, so let's decrease about let's say about 2. Let's try for 1.5. Okay, I think let's go to our isometric view. I make the screw in upside down version, so I think we have done it. Okay, we have done for the screw. Okay, alhamdulillah, so we have done our screw. This is example how we make a screw for our project. Okay, I hope you guys could do it. Use this video as a reference to do your screw object. Okay, thank you very much for watching this video. Assalamualaikum warahmatullahi ta'ala wabarakatuh.